All right, welcome Nordgaren. He's going to be doing a talk tonight on Huntress CTF, malware reverse engineering. Welcome Nordgaren, take it away.
Hey guys, my name's Nordgaren, and I wrote these challenges for the Huntress CTF. This one's called Rusty Bin. I guess we'll just dive right into it. It's actually funny. There was another challenge called Rustline, and the data obfuscation in this particular binary was inspired by Redline. It was a Redline sample that John actually found, or I found. I sent to John. I was like, this Discord malware that Mudahar, another YouTuber, was covering, and inside of it, it had this obfuscation that I thought was really cool because it was just passing random numbers to a function and is grabbing all the data out of the PE resource. So yeah, we'll see how that looks in Rust. It's very interesting, and I guess afterwards, after I take you guys through the challenge, I guess we'll look at the source code or something. But yeah, so this is just a normal Ghidra analysis. If you did auto analyze, there's really nothing special about it. The first thing I do actually want to do, I did this because sometimes it takes a while to analyze the binary, but the first thing I actually do when I get a new PE is I open it in, I think I've already opened it, in O&O editor. You can do any editor that'll allow you to look at the sections of the PE like this, but you can get a lot of good information. You can get information about the base of the code, the entry point. If you remember this number, you'll see it in Ghidra. Actually, we just look at it. It's right here, the same number. You can get that information from here. You also have DLL characteristics. And this is an important one here because when you're reversing a binary, usually you have you don't want to turn this off, but this dynamic base here, this is actually going to affect your ASLR. We're going to save this, not for Ghidra, but later we're going to use x64 debug. And what this will do is it'll make it so that we keep our base address. It just makes getting addresses from Ghidra over to x64 debug a little easier. After that, we got our sections. You can look through your sections, see if there's anything weird. You got your six sections, so nothing odd going on here. Your DLL imports, this could be important if you needed to, say, inject code into the DLL and you needed to proxy bcrypt or something. You get that information here. And then at the very end, you also have this resource directory table. And I always like to look at this because there could be fun stuff in here. Remembering these first ID entries, because this is the first ID that the resource lookup has to go through. We can see that we have all these integer IDs, and one of them is going to stand out a little later. Okay, so we're going to save the binary so we don't forget later. We're going to go in here, and we are going to jump into looking for the user main code. So this is for an MSVC binary built with Rust. Rust has different targets. MSVC toolchain is one that you can target, and the entry point looks a little bit like this. It's got the security cookie, and it jumps to this function, and you get all this code here. Most of it actually doesn't really concern you. This is all startup code. But importantly, after here, this pargv and pargc, you have this function here that the argc gets passed into. And inside of it, you have, this is actually, I think, a Rust intrinsic function or compiler function that also does more Rust startup. But this label here, this is actually your code, the Rust code. That gets passed in the first thing here, so it's going to get called later, but we don't really need to mess with that. When you come to this label, it's not going to be identified as a function, I guess, because Ghidra doesn't really know that it gets called later. So what you can do to clear this up is you can go to your first byte here and hit F, and that will make it a function. This takes a long time to do if you're still analyzing, so it's another reason to analyze your binary before you start actually analyzing it yourself. And then you are in the main function. I don't know, should I stop periodically and ask if anyone has any questions? Or
Sure. However you like to do it.
Everyone pretty clear so far? Just kind of like disabled ASLR on the binary for later. We looked at it and we went through the entry point. We found where argc and argv are being passed in, and then we found this label, turned it into a function. All right, so sorry if I'm going too fast, but feel free to let me know. So this first function here, this is all stuff that I wrote mainly. This is getting into like my code. This first function oddly passes a 0. You'll see why in a second here when we go into it. And I mean, of course, you're going to start at the top of the function because like where else are you going to start? Unless some other people, like they'll start with dynamic analysis and they'll like breakpoint like some function that they know is going to get called because it's going to print something to the screen, and then they'll follow the stack up. Because I know where the rest function or where the rest of code takes you, I just feel like this is the easiest way to get started. So inside this function, this is the first function of the whole binary. We have this other function call immediately, and actually Gidra's really intelligent here and tells you that it's getting the PEB, and you can actually see that. It's a little hard to see because it's zoomed in, but yeah, you're getting the GS offset process environment block. And then, so what do you guys think that's going to be, right? That's going to be, going to hit L on the keyboard to rename the variable. It's going to be the PEB, and it actually looks, hey, if param1 is 0, we're just going to go to the PEB plus 16, which is actually the base address of the binary that of the executing process. For some reason, Rust thinks that there's a second parameter here. There isn't. I guess it's used. I don't really know. It's used a bit later. This is more for, I mean, what do you could probably guess it's going to go PEB crawling. So we can go back up. We can hit L on this function and name it get PEB. And also just for later, just in case, user main. And then we see this funky thing here. I could tell you what this is now, but actually I don't even know if we really run into it because the way that I solve this, I don't really bother looking at any of the code that uses this. This is a encoded pointer. So what I have done is I have encoded the pointer gotten back from the PEB with the last bit set. That actually specifies whether or not the binary is mapped, which is important when you're trying to look stuff up in the binary, right? Then after that, after we encode the pointer, for some reason, Gidra or Rust generates this code, which I think it's trying to put like, this is 64 here, OX64, this is A. So I think like it's put like the integer 10 here and then 60. So it's, I don't know why it did that because it never uses it again. That's what I was, I don't remember if I said in the beginning, Rust code generation is very interesting. Sometimes I'm wondering if it's just kind of obfuscating itself for me. It's very fun. So we just kind of like follow down the path and label things as we go. That's kind of like how I learned how to reverse things. So we know this is the module handle, and we'll say it's the encoded module handle. And now we see the next function that really pertains to us is this one where the encoded module handle gets passed into. So we can go into this function. And let's see. Basically just start looking at what this function does. There is some bit of like needing to know some stuff about the PE that goes on with reverse engineering in general. This stuff here, the encoding, obviously not. But what we're going, this is going to de-encode the pointer. And it's just going to start looking through the PE, because at the base of your module is your PE, right? So at the PEB, once you have the module handle, this is going to give you that MZ header if you read it as bytes. And to traverse that, the first thing we do actually, and I think I can. Oh yeah, you can type this, but it kind of screws things up. But I will show you this because it is important. Is it? Yeah. So you can retype this as an image DOS header, and you can kind of see what it's doing now. It's getting the E alpha new and adding that to the base address. I don't know why it kind of messes things up when you do that. So I'll put it back to find 8. So it's getting the alpha new. So we know that is empty header offset, and it adds that to. Man, I think Ghidra just messed up my. This is another thing you have to worry about with Ghidra, is sometimes when you type a variable, it like reanalyzes the function, and then for some reason it doesn't understand that this is this. So just imagine it didn't do that, and we got a perfect decompile here. And then it adds 4 for some reason. We'll see why it does that in a second here. So we will nt header plus 4. And then we're going to keep going, basically. We're going to do these checks here. This is where I was talking about having to know stuff about the PE. The PE has different formats. There's like all these different versions of it because you've got Windows on ARM, you've got 32-bit Windows, you got 64-bit Windows, and all these different architectures have headers. When I was first disassembling this and looking at it, it took me until the second loop here, or the second if statement, the else if, to figure out what was going on, because I saw this AA64. And I know this is one of the machine types that it can be. And this 8664, I also know this is another machine type. So this +4 is actually the offset to the first, to the file header, the first field in the file, or what is it? Yeah, isn't it file header? What is it? Image file, yeah, file header. Apparently it doesn't have it. Ghidra doesn't have every definition, and sometimes you try to import them, it's hard. But this is actually your machine type. I'll see later if I can show you guys a definition of the headers. Actually, we can look at that here in O&O editor. This is your DOS header. This is that alpha new here at the very end of it. Oh, yeah, they called it address of new exe header. This is the DOS stub. So this is basically telling you to skip over this. Here's your NT header. And into the NT header, 4 bytes into it is your file header. And then your machine is the first short. And we can also check because it is reading a word pointer, so we know it's actually reading a short here. So it's going to be checking the short against these values. I found a lot too, by the way, that especially with like challenges, we were talking yesterday on John's stream about having to have a goal. And I feel like that's the same thing in RE, because I could sit here and reverse this whole function, which, take me like a little bit of time, but I already know that it's parsing the headers, and I know that these are 2 other params I got passed in, and I can middle click these, and it will highlight it all the way through, and I can check that, hey, it's actually checking for these parameters. And in the function above, we have the the parameters get calls with, it's 10 and 100. And if we remember here, we have a resource directory. And we have 10, the ID 10. You have to dig down a little bit. The way that these entries are sorted out are kind of weird. But if you keep going down, is it this one? No, I think that is the... Oh, yes, here it is, integer 100. So this is the only entry in this 10 here. So we can kind of guess that, hey, this is probably getting that resource. And we can even probably figure that out. Go down all the way. Here's the resource here by using x64 debug. So what I'm going to do here is I am going to grab this address. We are going to open Rusty bin. And I can do this. And I can go straight to the address since we disabled that ASLR. I'm going to set a toggle a breakpoint here and run it until we get over there. And then we can step over, and in RAX, we've got this. And actually, that address looks really good. Did someone say something?
Yeah, hey, can you go back one step? I was just curious how you got that memory call on there. Like, what brought you to that specific one again?
Like, what brought me to that memory call?
Correct.
So this is the very beginning of the whole like user main function. And this thing, we pass in the module handle in. Well, we pass a reference into it. It gets dereferenced, and then we check the machine type. And then I kind of like I said, when you know how a PE works, you know the things that are in a PE, right? You notice I was checking machine type. What happens next? Okay, well, we can look here next, the NT header offset plus 9C. And that actually ends up being, I believe it actually puts you like right here at the section headers. No, it puts you at the end of the optional header. I'd have to do some math to show you this, but this is 80 plus these two structures, which is 14 and 4. So 9C would bring you, forget if the math brings you to either right here or to this data entry. And this is your resource data entry, which is the thing at the end, which I showed you that has this resource table in it that has the 10 ID. And we also know that function is being called with not only 10, but it's being called with the integer ID 100. And so now I'm just curious, is this function returning a pointer to that resource, right? So I just go back up one, and then I go to that call, and I'm going to check. Well, we can check this RAX afterwards to see. Did I explain it?
Yeah, no, you got it perfect. Thanks. Appreciate it. I was just like, wait a second, how did you get there?
Yeah, sorry. It is kind of guesswork, but it's like I said, like if you look at this file format a lot, which I look at it a ton, right? I mean, it's in every single RE challenge that involves a Windows binary. You're going to get an exe. So you can kind of take these guesses, because otherwise it'll take you a little bit of time to reverse these functions, and you're basically like, well, I'm just reversing something that's very basic. It's just getting the resource from the PE, right? So after that call, though, so we're here now at this test REX. It's basically just going to null check. And in REX, we have our return. And I've already gone to it in this dump, but we can see that it is actually the same data as we have here in the resource. Go through it again. Sorry about that. CD A2 E918 OB. And you can see this like ice ale minus whatever. Yeah. So it's like, okay, well, now we know that this is get PE resource, right? And then this is going to be PE resource. This is going to be a pointer to the resource. So it's going to do our null check. This is a weird invention by Rust. And you can see it's asking, I actually don't know what the compiler is thinking here. It's asking if uvar10, which I don't know where that gets set. uvar10, let's see, edx. Yeah, no, it's this PE resource, right? So we return test rex, conditionally move rex into rdx, and then add 10 or add a0 to it, compare a0 to it, which is one more than 9f, and then jump if less. What it's actually doing something for this next function call, and we'll see in the source code. It's actually just checking if the address is less than these offsets, which makes no sense. I'm gonna have to show this to the Rust compiler guys because it's a little weird. But yeah, it does take this P resource, and for some reason, Ghidra doesn't understand that it goes here. Yeah, I'm pretty sure it does. Well, I mean, it has to because it's adding these offsets. I don't know why Ghidra is always like that. It doesn't always give the best decompiles. But yeah, we can see this next function. We just keep going down the functions. It's going to take the pointer. It's going to add some stuff. Whoop. Define strings. That's not what I need. It's going to add some stuff to it. This one adds this A0 offset. It's going to also pass it in with this number. And then it also takes the pointer and adds this offset. And it has this number. And then for some reason, it passes in this local D8, which hasn't even been messed with yet. And this is another part of Rust that is very interesting. I think C++ does this too. If you have like a constructor function and it's supposed to return self, and it's a big structure that it's returning, instead of returning like something or whatever, it just says, hey, pass in an out parameter as the first parameter, and then that'll be your return. So we know that this is the return. And this is resource plus A0. And you can, I mean, if you can just remember these, like what these are, like you could just call this resource 1 and resource 2. I'm just kind of naming them so that we can remember stuff. I don't remember the offset, so I'm just going to call it a lot. And unc num 2. And then once again here, we can kind of take some shortcuts by using this like clicking method. Sorry if this is very weird looking in the window. By right clicking stuff or middle clicking stuff and kind of seeing like where Ghidra shows us it's being used. And we can see this return here. First of all, there's a if-else statement, and the if-else statement is checking if num is less than 0, else it does a whole bunch of stuff. Yeah, and then it checks it again. Sorry, I don't remember this. This is very weird. Anyways, the thing that actually caught my attention here when I was looking at this function and just initially kind of clicking around was this like mem copy here, right? Like this is very weird. There's some kind of destination here, and Ghidra's already actually labeled that for us. So let's go into this function. Well, we kind of have, let's see, this function. Oh, hey, heap alloc. So what about this one? Oh, hey, another heap alloc. I think if we find 2 heap allocs and both of them are returning something, that is probably allocating something on the heap. That's my guess. So we will call this heap alloc. And then there's a destination. I'm like, this is interesting. Where is this destination going to end up? Because it's copying stuff too. Actually, it immediately writes it to the return bracket 1, which it thinks the return is a u-long pointer, and since it's a pointer to anything, it's going to be pointer size. So this is the first pointer size area. It's set to unc_num. The second pointer size area or array or item in that array gets set to destination, which is a pointer itself. And then the third one gets set to unc_num again. This is another thing that I found was weird with this binary in particular. What I'm going to show you here, I want to breakpoint this function again, right? So like we did this one earlier. I want to check this function because I know now that the first pointer size type at this pointer here is going to be a length, and then we've got a pointer, and then we've got another length. So if I take this address, and go into Ghidra, or go into x64 debug, and I breakpoint F2 to breakpoint, by the way. What you want to do is you want to continue running until then. You don't want to step over yet, though, because you need this here, this RCX value. If you're not familiar with Windows calling conventions, RCX is your first parameter. And you can follow that. And we'll see, actually, there's really no data or junk data here. But as soon as we step over, we get our data populated. And now we see this 2 4A, and then this value here. And this one? Yeah. So this value here is your other pointer. There's a very weird heap location, but this is apparently a heap location. If you highlight it, right-click, follow and dump, it will take you here, and we can actually see we have some plain text here. So this is kind of like part of what I wanted to get people to do in the challenge was to have to either find a place to hook to get the data out, or to actually reverse engineer the data themselves. Because of this, I made basically a custom file format. This is not something that I would expect you to see in Malware. I just thought it would be like a good hint in case anyone was doing this and they were like, okay, I want to breakpoint here and see what the out parameter gives me. When you breakpoint, you see this HNTR. This kind of looks pretty obvious to me, right? And if I just keep scrolling, well, I've got a bunch of data, and we had that. What is that? 2 4A. This is actually quite a bit of data. So one thing I could do is I could dump that data. This is not how I solved it, but I just wrote a whole Python script. But what we could do, and I did want to show this because I love hex editors. We can open. Sorry, my Python is not great. B as F dot write. Is it write data? Yep, I think. And we'll just, and if I just I do something wrong, I'm sorry. Oh, yeah, I used to call this I'm a malware until John named it Rusty Bin. I am not the type of person that likes naming things at the start anyway. I feel like if you spend too much time on the starting point, then you're going to have a bad time. Hold on, I have a better idea. I don't know if you know about this, but in Windows, if you shift right click anything, you can copy as path. and that gives you a nice path to the thing, the full path. So let me just. All right. Well, apparently I can't because it's out of range. I might actually need to have updated this script. Hold on. Actually, does anyone know if you can dump data out of binary out of x64 debug quickly? Sorry, give me 1 second. Technical difficulties. I did wrong. I had totally done this like a different way, and then I cleaned it up because I didn't want to send in like this crappy Python script that was.
Totally fine. I'm still like wrapping my head around some of the stuff that how you got to somewhere is what really interested me.
Can I just do this in Python? Sorry, very professional here. No, I can't do that. Everything's also a little zoomed in here. Why did they change all my bindings? All my bindings are different in one IDE than the other. All right, I guess we won't do that there. Actually, I'll kind of like go back a little bit to show you how I got to that conclusion again. So we know that this is a pointer to the resource in that binary, right? And then we get this function call. And this function call has some numbers in it, right? Like this is somewhere obviously inside of the what's it called? Inside of that resource, right? Because it's not a very big number. And this one we can gather is probably also somewhere inside of that resource. And once we go in here, we can kind of get that just by thumbing through the what's going to go into this return here. This is something you may need to know about Rust, but you will also figure it out even if you just had this resource plus AO here and you're going through and you're like, huh, what does this do? Wow, this is being passed in a memcopy, which Ghidra is able to pick this up because this is a VC runtime function. That must mean that it's probably being copied somewhere, right? Does it? Yeah, it shows you the source and the destination. So the source was that second argument. The destination is something else. It's this dest variable here. And then I figured out this is heap alloc because, well, yeah, I just kind of went into it and clicked around and went down functions. I guess I'm kind of like impatient. You know, what I'm thinking here when I click into a function here, I'm like, all right, I see this here. It's being sent into memcopy. My mind goes to this is probably heap alloc, and then you just need to figure out where it's heap alloc, right? And turns out like here it is. So it is a little bit instinctual, I guess. Part of it comes from also just like programming and using pointers and like using these kind of languages. I haven't actually been doing it very long, but the people who taught me how to do all this reverse engineering stuff, they have been like 30-year programmers, and like as they apply their experience in a way that I kind of like try to mimic what they're doing, and I just try to understand these languages and machine code and like PE file formats like the best I can, so that I can like kind of make these assumptions as I'm trying to reverse something. Because otherwise, like we could be sitting here looking at some very nasty stuff for a very long time. And we have a goal, and our goal is really just to get the flag, right? Like, we want the flag. We know there's a flag here somewhere, and we just need to get to the next thing. And even if, like, let's say I breakpoint on here and I saw this, and this wasn't actually part of the solution, maybe this was a red herring or something, I think that's still kind of all right, because, like, sure, you didn't get to the goal, but, like, you checked this out and you have a little bit more knowledge about this, and you put some names in here and maybe even put some types in here, so that you can figure out a little bit better like what's going on, and you can come back to this later and you've already got a tiny bit of documentation, right? So, like, even if your bet didn't work out that, hey, this first thing here is going to be what I'm looking for, you still kind of, like, figured out something more about the binary. Does that make sense?
Yep, mostly following. I'll be honest. There's a couple of points I'm like, oh god, I don't know that part.
Let's see. Another thing you can actually do, and I would probably do this while I'm here with Ghidra, you can right-click on one of these variables, and since you see that there are actually things being assigned later on in the pointer, everyone knows, like, this is or does everyone know, like, this is pointer syntax, right? Like, this is dereferencing this pointer and setting this to whatever is at this pointer, and then this array syntax here is basically just taking the type, timesing it by this, the size of the type, multiplying it by this number, and then whatever's at that address, it's setting this to. Does that, I think most people hopefully will know that if you use C. If you don't, then, well, this is, I mean, some of this is actually how I learned how pointers work, honestly. Later, maybe I can tell you guys a little bit about how I started, but I mean, it really was just, I was using C#, and I mean, do you really need to know what a pointer is in C#? Not really. The whole language kind of does it for you. It's actually pretty awesome. But yeah, so right-click and auto-create structure. And this will actually create a structure. If you right-click, edit data type, you have this little structure viewer. And you can actually name these fields. Right now they're field OXO and stuff. But you could name this, like, resource, and you could name this length. The length thing I just kind of deducted because in a lot of these memory safe languages, they want you to have all of your pointers to buffers or anything have a length, right? Because if you don't have that length, then there might be a chance where you could overflow because you don't have a length to check against. And usually it's like they're right after each other, right? It's usually pointer to the data and then the length. This first one is very weird. I don't know why, and we'll see in the source code a little bit later. Yeah, it didn't work for some reason. Or it just got assigned there for some reason. There's, like, nothing in the code that makes me feel like there should be a length here, but it's there. So yeah, I'm just kind of betting here, really, because I don't want to have to reverse every single function. Especially, like, could you imagine, like, if you were your day job was just reversing malware, like binary malware? If you had to reverse every single function in the binary, it would take you a very long time to find the important stuff, right? So I am just kind of guessing here. And the fact that I got something plain text out of it makes me excited because this looks like a file magic to me. And then there's something that looks maybe like it could be a count. And, you know, a couple of other small numbers. This doesn't look very random data to me, right? This looks kind of structured. And that is, let me see. I'm going to try one more time to get this. Oh, you know what? I probably need to. Wait, what does it say? This is very weird. Why it won't oh, I put them at 0 and 0, that's why. So if you actually, so these are offsets, right? So if we did determine that these are offsets because this is a resource, we look in here, we see that this resource new pointer with the offset gets passed in as a source to memcopy. This has to be some kind of data, right? And then this unc number also gets passed in, and we know because of the call to memcopy that this is the size, right? Like this has to be, unless the programmer is a jerk and decides not to put the length as the size in the memcopy, which of course that's what you don't want to do, because if it's too big, then for the destination buffer, then you might overflow. So we're gonna assume here that the programmer is sane, although I guess side note, maybe they might not be, because maybe this is like a real malware that is trying to do things very weirdly so that you do make these guesses and they throw you down a rabbit hole. The other challenge had some stuff like that too, which was really funny. It was kind of pointing back to the other challenges, just kind of taunting people, I guess, telling people, no, this is a red herring, follow the white rabbit. Which, if you played the Huntress CTF, you'll enjoy that joke, maybe, or you'll hate it. I don't know. Let's see. So since I can't get the data out, I could actually just show you guys in the source code. Hopefully that's all right. I also have this solution.py. We can run it. If this doesn't run, then there is something wrong with it. Yeah, no, it runs. So it does actually get the flag. I just, for some reason, I'm unable to get it out with what's it called? I'm gonna try one more time. Actually, no, I'm just gonna show you guys the source code because it's pretty easy to understand. And you can even see it here in the hex editor. So you have your magic, you have a length, and then you have the offsets. And actually, you did have to kind of look through this because it's the ID and then the offset and then the length. But we'll see that here in the source code. So this is it. It's actually not very big. It's only 33 lines long. This is also the original name. I told you guys earlier that I originally called it I'm a Malware, which is half truth. I originally called it hidden XOR strings because I just went, what is this going to be about? Hiding XOR strings. Great. We'll just name it that for now on. It starts out with this build RS, and that's what builds this resource. In fact, you know what? Actually, aha, I'm saved. I think this is actually the bin. I just wrote it to disk. Yes. Okay, it is here. Cool. So we have this magic now. This is the same thing. I just grabbed it out of the source code because in the build file, I wrote it to disk as well. So good on me for doing that and not forgetting to test it. But yeah, so once we see something like this looks like a magic to me. This looks like something. It looks like kind of a weird number because maybe it's big endian, right? And then we have some other values. These values are different because I shuffle the binary every time it's written. So like this is 539. This is the ID here, but here it's the ID 0 actually, because it got shuffled differently this time. But you can actually see that you have this 158 and then this 4 blank. And then there's a couple other, there's 9, 1 5 C5, and then this 2 length. So if we're going off of the idea that we have these 3 things as one structure, we should probably first check that actually. And we can. So we passed in this this RSP plus 30, which is D8, into this function call, and then that got populated right by the destination that was set here, or the pointer that was set here. And that, since this is on the stack, right? Like this is on the stack at RSP plus 30. So RSP plus 38, which gets moved into RDI here, that's going to be that pointer, right? Because of the structure that got laid out. This is 0, this is plus 8, this is plus 10. So 30 plus 8. And then the next one's going to be that length, which, again, like I said, it usually is this order. Oh. Sorry, did somebody want to say something?
Oh, no.
Gotcha. No, just making sure. So we can see that these fields are being accessed by the offset from RSP. This one gets moved into RDI. This one gets moved into R8. And then we have something else being moved in to, oh yeah, this is loading the address into RSP plus 60. So this is, you don't actually see it right here because it actually then passes that to RCX. But this is going to be your first parameter because it's an RCX. Then that RDI from RSP plus 38 gets loaded into RDX, and then we get the function call. So we now know that this is going to be like, it's going to be the return. This will be the, so this is the data and the length. This is all getting passed in here in this function call setup. There's a little verbose. Again, like I said, is Rust just kind of obfuscating things for me because, you know, we could have just loaded this in the RDX and then, you know, loaded this straight into RCX. I don't understand why we didn't. But it is fortunate if you're trying to make challenges, or if you're a malware author and you're trying to hide what you're doing, it does make things quite annoying. All right, so we're going to go into that function, and we need to rename these things again. And we see the length is less than 4. You know, we're like, this looks kind of junky. And then we actually, if length equals 1, else memcopy. That's kind of weird. I don't know why it does that, but I do know that next it's going to check something. And this value here is actually really important. I don't know why it doesn't show in Ghidra. Even if I right click, you're able to change the character type. But for some reason, it doesn't actually show you the characters. But if we go back here, I want that to be decimal. Is it decimal? If we go back here, we can see, because it's little endian, that 52, 54, 4E, 48. And in Ghidra, we have that 52, 54, 4E, 48. So this is actually checking for that hunter magic. And it actually even says here, we have this invalid magic string. So again, we'll just trust that whoever made this is sane, and that this is actually a check for magic. And obviously, it's going to early return if it's invalid. So we could probably guess that this is parsing everything. If that's the case, it's copied the data over to this local C9. We just keep working through it. And actually, I think maybe Rust did some weird stuff again with the obfuscation. I remember this being kind of odd. So it gets like the length. Oh, it's because it's like parsing through all the data. But we do eventually get to. Is it? Yeah, this is all just like regular Rust, and like this whole function here gets written out like this just to read the repository. Okay, yeah, so I don't want to take up like too much time reversing this function. You would actually, if you wanted to like not guess the file format, which it is totally valid, like you could guess this. I know people who do this. Like you could sit here looking at this because you can see that you have this E here, and you could guess, and people do this all the time with file formats, that this E means that there is this amount of entries, right? And you can see that up until the junk data, you actually have 150, which should be.
Sorry about that.
Oh, it's all good. It should be somewhere around like close to this. The setup is actually that there's two arrays. So you would do, oh yeah, it's E times 3. You would basically do some math. Sorry, kind of like escapes you right here. You'd basically take this as a count, right? So you're taking this as a magic. You're going to guess this as a count, and you're going to guess this as a little endian, which actually ends up happening more often than you think with file formats, so that they put stuff in little endian for whatever reason. I think it's a good technique if you're a malware author, because people might not guess that things are a little endian. And you would know that, what is this number here again, 14? Like if you took this and you divided it by 14, you'd eventually be able to settle on like, okay, there are 3 sets of 6. It would actually be 6 because it's doubled up. There are 14 sets of 6 in here, right? So you do that math, and then you start looking, and you're probably going to error a few times because you're going to guess like, okay, this is just everything in order, right? But see, E times. This is the fun part of reverse engineering.
The part they don't talk about in the textbooks, right?
No. Yeah, the part where you're staring at your screen going, oh, what do these numbers mean? And then losing your mind because you're like, what do these numbers mean? People always ask me, I post this bald cat with no ears all the time. Like, why do you post them all the time? It's like, that's just my face all the time because I'm always reverse engineering. I'm just looking like I got no thoughts. So yeah, EC divided by C. So if we took this whole thing here, right, we said that this 150 divided by C, which is 14. That's what I was doing wrong. We have a bunch of things that are 28, which is double 14, right? It doesn't really look like it would match up with the 28 either. So we could probably guess that this is 3 as well, because we've got a low number, we've got a high number, and then a low number, and then a low number, high number, low number. And then that pattern kind of breaks because these first numbers are IDs. So there is like trial and error and just kind of trying to recognize patterns in numbers with reversing file formats. The other thing you could do, and and this was actually somebody made a write-up. Since you know that this function, or if you deduce that this function is returning something that's gonna, check for IDs and stuff, and then you find these IDs in the wild. I think this might be one. Yeah, 537 is 1335. You could hook the function that gets that ID, or that, which it looks like it's this one. You see, like, this function keeps getting called. It gets called here with some weird number. It gets called here with some weird number. And this, I swear to you, this is how I reverse engineer things. I just look at, like, where are things being used, and I try to find important things. Sometimes it'll be data that I've breakpointed on because, like, I've been, dynamically debugging, and or sometimes it might just be I'm looking for the call to, like, write out to the what's it called, buffer, to the out buffer. So I mean, like, it is a lot of, like, my techniques are a lot of jumping around, but I feel like if I were to sit here and reverse this whole thing, that is 360 lines of C pseudocode, I would probably, one, go insane, especially since I have to, you'd have to do each one of these functions too. But two, I'd probably never get anything done, right? So let's see. Back to the source code. So this is the build of that file. It comes in here, and it makes the repository. I really like extrapolating things, and so I made this, like, XOR repository, this whole XOR repository structure, which has got all the entries in it, and it has a 2 binary function that takes all of the strings. It gets the length of it, does all the math, does the math for, like, where's the actual start of the repo going to be, how many strings are there, blah blah blah. It gets all the entries. This is so I can shuffle everything differently every time, and then it basically just writes out all that data into it shuffles them, and then it writes it out into a vector. So it writes out the magic, then it writes out the length. You could use something like surd, but I think you'd end up writing something similar to this anyway. Yeah, so after that, it gets built into this resource, which is done by a Rust crate that builds Windows resources, and this other crate called Ember that I made that does this whole XOR nonsense. So I called it bin. I just called it binary, and put that out slice into it, generated some random bytes. This is another feature that Ember creates, is that if you want to, you can generate a new set of, like, well, it's a one-time pad, right? That's what I guess an XOR, that's the length of the data that you're XORing if you have, like, random generated data. So you could generate a new one-time pad for each resource, which is pretty nice. Throws that up to the PE. It also puts on an icon. I did this for, like, continuity. So I knew that these two challenges would be, this one would be going out first and the other one would be going out second. And the other one actually hides data in that icon file. So I wanted both of these challenges to look the same so that the other challenge didn't go, oh, this one has an icon, I wonder where he put it, So yeah. So this was just kind of like foresight. And then this is something you have to implement yourself, kind of, but it's like a trait from that crate that I made for getting, like, PE resources. This is the Git module handle that I wrote. It's just your basic peb crawl. It's actually very bad. I've made much better since then, but I have to update some of my stuff. I'm not the best at that. This is the PE thing. I call this from pointer assumed map because this is not the actual way to get the PE, but I didn't want to use the same format of like getting the resource and like tagging the PE and everything because they would be the same in both challenges. So I didn't want people to just be like, oh, well, obviously I saw this code in the other challenge. I'm just gonna name it. They don't get to see this code at all. And actually the real one is kind of a pain in the butt because it goes and it checks like the IAT, it checks the EAT, and it checks all this other stuff. So what's all? Oh yeah, this builder puts all the information that I get here out of these constants into a constant file, and that gets included. This gives you the resource info, that A and 64, that's 10 and 100. Once you get the data, you have those offsets to the data. These are different because, again, they get generated differently every single time. Then I can de-XOR that data through that XOR repository, etc. And then I just kind of do the basic thing. You know, if you actually run this, it'll say something like, what is the password? And you could have started that way. I mean, maybe I should have started that way because most people will run a bin if they're like trying to figure out a CTF. The password here is just password. No, actually, I called it Rusty is a cowboy. If anybody's a fan of Venture Brothers. And you get the password correct, it gives you a clue. Some people said that they didn't get anything good out of the clue, which was very interesting because I'm like, well, this looks kind of like a hash value, a little bit, or just some gibberish. I do believe one of the clues I left, I just hard coded. I didn't want to allow it to like do any of the flag values because if I did, then maybe you could just run it over and over again and get the flag, or at least get most of it, and then you have only 8 parts and stuff. But
quick question: how do you get a hash value out of those 4 letters? What's the giveaway on that?
Oh yes. So the let's see this. I reloaded and it's now new values because it got remade. But it turns out that there are 10 different entries. Let's see. I think this is also in the build. So I just chunk it out to 4 sizes, and then it ends up being like 10 different ones or something like this. The slices of 4, right? So
it's just part of the hash.
Yeah, so it just slices the hash up into 4, and then it adds them sequentially as 1, 0, 1, 2, 3, 4, 5, 6, 7. So that way you have to go through and like go through each one, because if I just made the flag into one of the entries, then you just decrypt it and be like, oh, I got the flag. But now you got to kind of think like, okay, well, I only got like this flag with a it just says flag. I mean, that doesn't help me, right? Or I just got these 4 and it's like this little bracket and these 3. That doesn't really help me. And then you see that there's all these other IDs, and the data is just split up in a sequential order. I actually learned some interesting stuff about that. If I hadn't made them, if I decided that instead of like enumerating and starting at 0, if I decided to start at like a random number in like the high thousands, some people wouldn't have gotten it because some people actually just found where to hook and they just let the program spit out all the strings for them. And they just enumerated from 0. And since the flags were at 0 through 9, they got it immediately, you know? Yeah. Anyone got any questions for me, or like anyone want me to explain anything a little bit more about the binary or about what I did? Anything like that?
I don't have any questions, but this was I just want to thank you. This is I specifically did not do any of the RE challenges for the CTF because I don't really have any experience with it and didn't really know where to start. But this is like a really great intro. I got a lot of stuff to look up and get more familiar with. So thank you for going through it. And I like the I don't know, for lack of a better word, like the ethos for going through the challenges. The risk of oversimplifying, kind of, you're saying don't miss the forest for the trees. Like use your general knowledge and just like leaps of logic to get from point A to point B for like the CTF mentality to find the flag. So I appreciate that because definitely am guilty of getting bogged down in details. So.
Yeah, I mean exactly right. Like if you sit there and you're looking at something for too long, but you didn't just think like, well, this is a PE file, and like the last thing that I was looking at was a pointer to a PE, and it adds something to it. Well, obviously, like those things are all related. Maybe I should just look at if this is just grabbing that resource, you know?
Yeah, definitely.
Can I post some, like, I do have I mean, there's John's channel, obviously. We don't do a whole lot of binary RE, although we're trying to do more of it, trying to help with the content of doing more binary RE. It's very complicated, right? It's very hard to show in a very succinct way because, like I said earlier, you might need to know a lot of stuff before you even like start getting some of it that has nothing to do with what you're looking in Gahedra, right? You just might need to know the general format of a PE file, and or you might just need to know a little bit about the language that you're working with. Like this ampersand string here, I know that the compiler is probably going to generate a pointer, and then right after that pointer, a length, and that's what this structure is going to be. And that's just a thing that I know about the language. There's nothing that I could just like look at that and be like, stir and click through and be like, oh yeah, this is the definition of it. I just kind of have to know that. I think even with like a vector too, like a vector, yeah, see it's got this buff raw vec and then a length, and then this raw vec is actually also a pointer and a cap, which is another length, right? So this is pointer, length, and then another length. Luckily, this is something you can see in the API. Another thing about Rust though is that it doesn't have an ABI, so this is not a guaranteed layout. The compiler might actually put the buffer after the length, but I haven't really seen that before. Maybe that's what it was doing with that pointer we were looking at earlier. Like maybe it had put the buffer after that length or something.
For folks that are new to Rust, malware, reverse engineering, do you have any good resources you could share?
Yeah, can I post like I was gonna ask if I could post another channel. There are 2 channels.
Yeah, use the Meetup text channel.
And so this is Josh Stroshin. I don't know how to say his last name. I'm sorry. Dr. S. He's a great channel. Does a lot of binary RE stuff. He has some playlists that you should check out that are just the Ghidra and the binary RE playlist. He goes through, he teaches you to like kind of build your own software, and I recommend this to everyone, right? Just build something in C, build something in C++, build something in Rust. It doesn't matter what it is. Build it, throw it into Ghidra, analyze it, and then see what gets, and what gets output. Or spend a little bit of time with Godbolt compiler. I don't like Godbolt that much because it's cool for small things, but like it doesn't give you any context for a large program. And with a programming language like Rust, a large program can really affect the output. And then the other channel is OA Labs. And then, of course,
I was about to ask you, you know, what's your number one resource outside of John Hammond? So,
you know, it's funny. So, like I said earlier, I got into this with like game hacking, right? Like, it started a couple of years ago. I was just playing a game, and then I decided I wanted to help with this mod that I was playing, and then I had to maintain this trainer because nobody else knew how to, and I felt like, well, we're gonna figure that out. And that was kind of also my first introduction to reverse engineering, because even though it was C# code and it's all plain text, I had to like figure out what the program was doing. And I actually at that time didn't really know anything about binaries and PEs and how they worked. And that project taught me a lot because it's basically a cheat engine table, but in C#. So I had to learn like what a function is. I had to learn what the stack is, what the heap is. I had to learn even how to like assemble, use like write assembly code and execute it in another process. You know, so I learned a lot from that project, and the people in that community helped me a lot.
I need to know, was it Gary's mod?
No, it was actually Dark Souls 1.
Okay, cool.
But I actually, most of my life grew up playing those games, Half-Life, Counter-Strike, Gary's Mod. So I've been a modder most of my life. I just never was on the making side of things. Now I'm kind of doing that because I'm really interested in just how computers work, you know?
Absolutely.
Anyone else got any good questions? Anything else I can like go over? I would say like oh, go ahead.
oh no, what I was gonna say is if we once I can thank you for before Sean closes the stream because we're live streaming and recording. I could we can close the stream and we can have like after hour more conversations if people want to talk up but don't want to be recorded. Totally respect that. So just real quick, kind of wrap up this part. I just want to thank you for presenting. I know everyone followed 100% throughout every single step.
And I know it's the best possible teacher.
No,
perfectly.
I'm not good by any means, but I learned some different techniques on how to like, okay, that's a different way I can follow the references. But I really appreciate you. I know we're going to close the stream for those that are on live stream outside of Discord and you want to get a free certificate, just get to join our Discord and you bang cert me and you will get a certificate. The only thing we record is a hash. We don't want to keep our names of anybody. So just want to throw that out there. But yeah, again, appreciate you. We're just going to close the stream and continue conversation.